Okay, the question says the commuting time for a student to travel from home to a college campus is normally distributed with a mean of 30 minutes and a standard deviation of 5 minutes. So I'm processing that information. So the mean is 30 minutes and the standard deviation of commute times is 5 minutes. The question says if the student leaves home at 8:25 a.m., what's the probability that the student will arrive at the college campus later than 9 a.m.? So I'll define a random variable x that stands for, say, commute times in minutes. I'll sketch the normal distribution. The mean is given to be 30 minutes. The standard deviation is given to be 5 minutes. So if the student leaves home at 8:25 and arrives later than 9 a.m., it means his commute time x should be bigger than 35 minutes, should be greater than 35 minutes. And the question is, what's the probability of that? So in simple language, what's the probability that x is greater than 35 minutes? So I'm going to sketch and label this information. So I just need this probability. The area under the curve will depict that probability, will describe that probability. There are multiple ways to do this. Method one is a simple calculator approach. The command is called normal CDF. Okay, so if you have a TI 83, 83 plus, 84, 84 plus calculator, the command is called normal CDF. You hit second variables, it gives you distribution, scroll down to normal CDF. The format of the command is left bound, which is 35, right bound of the shaded area, which goes on till infinity, so you can write, say, 9999, and then the mean, which is 30, and the standard deviation, which is 5. And you can hit that and get an answer. Check if it is very, very close to 16% or 0.16. It's very likely to be 0.159 something. So it's roughly 16%, which is part A, okay, or rather choice A. Another approach uses, say, z-scores. I can calculate the z-score corresponding to 35, which is how many standard deviations above the mean of 30 minutes is 35 minutes. And the formula is x minus mu over sigma. It's smart to also know how to do it this way. So it's 35 minus 30 all over 5. Upon simplification, it gives you 1. So in other words, the question then really becomes, what's the probability that you have a z-score exceeding 1? All right. If you recall something called the empirical rule of thumb, okay, so it's called the empirical rule. Empirical means from an observation or experience. In a normal distribution, 68% of values lie within one standard deviation. So if this is 1 and this is -1, you have 68% of values lying between -1 and 1. Therefore, 32% of values will lie beyond one standard deviation. So in other words, this total area will be 1 minus 0.68, which is 32%. And since the normal distribution is symmetric, that's 0.16 and that's 0.16. So the probability that z is greater than 1, probability that z is greater than 1 is nothing but 0.16. So that's method 2. It uses z-scores to answer the question. This is an approximate rule, so it gives you a very, very good estimate though. So it's